Welcome to the next lecture of the CBNST. In today's lesson, we will talk about solving the simultaneous linear equations. In the previous lesson, we had seen the Gauss-Jacobi method. In today's lesson, we will see Gauss Seidel method. Both the methods are very much similar to each other. They are similar in terms of the primary condition, but they are different when we perform the iterations. So let's see how Gauss Seidel method operates. So this is let's consider that this is the simultaneous equation system with three equations where we have three linear equations, and we need to solve these three equations to find out the values of x, y and z. So before we talk about the method will be applied on this equation if this will hold the diagonal dominancy. What is the diagonal dominancy? Let's talk about diagonal dominancy. So in this first equation, the mod of a1 should be greater than the mod of b1 plus mod of c1. So that means in the first equation, this term, the constant of this term, coefficient of this term dominates. So in the second equation, the coefficient of y should dominate. That means the mod of b2 should be greater than mod of a2 plus mod of c2. And into the third equation, obviously the coefficient of z should dominate. That means mod of c3 should be greater than mod of a3 plus mod of b3. So if this condition is true for any simultaneous linear equation system, then we can apply Gauss Seidel method onto this particular system. So let me show you an example of this diagonal dominancy. Let's say if this is 10x plus 2y minus 3z, and let's say 2x plus 8y plus z, and let's say minus of 10x plus 21y minus 7z. So if this is the first equation, this 10 should dominate. As we can see, we have to take the absolute values only. So this is 10 should be greater than the sum of 2 plus 3, that is 5. So this is 5 and obviously 10 is greater than. So here we can see that this term is dominating. In the second equation, the term of y should dominate. So this is 8, we can see 2, and this is 1. So 2 plus 1 is 3. Obviously 8 is greater than 3. So here this term is dominating. And in the last equation, okay, let me rearrange this. Let me say this is 71z. So in the last equation, the 71 obviously is greater than the sum of 21 and 10. Remember, we are taking the absolute values. So this system is showing you the diagonal dominancy. So that is because we are talking about the diagonal, the first element in the first equation, the second element in the second equation, and the third term's coefficient into the third equation. So such type of system can be solved with the help of the Gauss Seidel method. Let me show you one more example. If we have a linear system of equations, something like this, let's say 2x plus 3y plus 7z is equal to 3, 9x plus 2y plus 3z is equal to 4, and x plus 8y plus 3z is equal to 3. If we have this system of equation, then whether this diagonal dominant, let us see. In this, you can say in the first equation, this first term is not dominating. Which term is dominating? This term, last term. So let me highlight this. This is dominating in the first equation. In the second equation, which term is dominating? Not the second one. This term is dominating. And in the third equation, which term is dominating? It is dominating this term of the y. So we can see in the first equation, the term of z is dominating, here x and here y. So we can rearrange these equations. What we can do is we can call this equation as equation number 1 because the term with x is dominating. Now we need to find out the equation where the term of y is dominating. So this is, so now we will make it second equation and we can make it the third equation. So in this way, we'll rearrange these equations. We'll write this on top, first equation, then we'll write this equation, and then we'll write this equation. And at that case, the system will become diagonally dominant, and then we'll be able to solve it. Now let me show you one more example. if let's say in the third equation we have something like this, 10x minus 3y plus 2z is equal to 3. So we can see in the third equation which term is dominating? 10x. Will this be a diagonally dominant system? No, this will not. Why? Because we can see in two equations the similar term is dominating. This is x and this is also x. So we will not have a diagonal. For that, we will not be able to rearrange this. So this is non-diagonal dominant, right? So I hope you have understood the concept of diagonal dominancy. Now let me talk about the Gauss Seidel method. If a system follows this diagonal dominancy, then that can be solved with the help of the Gauss Seidel method. So let's imagine if the initial values of these x, y and z are given as x0. So if these initial values of x, y and z are x0, y0 and z0, then we can begin with the first iteration and we'll find out the values of x1. So how we can get this x1? By substituting the values. In this we'll substitute this as y0 and z0. So just by substituting y0 and z0 and all other consonants, we'll get all other coefficients, we'll get x1. Now here comes the difference between Gauss Seidel and Gauss Jacobi method. In the Gauss Jacobi method, in each iteration you keep all the older values. So to calculate y1 we used to keep x0 as well as z0, but in Gauss Seidel method we update the values. So now as you can see, we have a new value of x1. So just to calculate this y, we will use this new updated value of x1. So here we will substitute x1 and this z will be the older value z0. So this is the difference. And this is how we will calculate y1. Now just to calculate z1, we can see we have a new value of x, that is x1. We have a new value of y, that is y1. So we will keep these new values x1 and y1. So in this way we will be able to calculate z1. So this is the difference in between the Gauss Jacobi and Gauss Seidel method. Now let me show you. This was the first iteration. In the second iteration, what will be happening? So in the second iteration, that means we need to calculate the values of x2, y2 and z2. So just to calculate the value of x2, what we'll keep here? We'll keep here y1 and we'll keep here z1, the older values. But to calculate y2, we'll keep this new value of x, that is x2, and z will be 1 only. To calculate this z2, we have two new values, x2 as well as y2. So we'll keep these two new values, that is x2 and y2. So this is how Gauss Seidel method moves further. So now let me explain you this method with the help of one example. Now let us consider this example and solve this example with the help of the Gauss Seidel method. Before starting the method, let's check the diagonal dominancy of this system. As we can see in this system, what is mod A1? This is mod A1 is 27, should be greater than mod of 6 plus mod of minus 1. As you can see, this 27 is greater than 6 plus 1, that is 7. So in the second equation, this 15, so mod of 15 should be greater than mod of 6 plus mod of 2. So this is also true. So we can see the first and second conditions are true, and the third equation, this term of z. So mod of 54 should be greater than mod of 1 plus mod of 1. This equation is also true. So we can see that this system is diagonally dominant system. So we can solve this with the help of the Gauss Seidel method. So now let's start and solve this with the help of Gauss Seidel method. Let us assume that the initial values of these x, y and z, that is x0, y0 and z0 is equal to 0. So we'll start with our first iteration. In the first iteration, x1, so x1 is equal to, now we can see this is the formula, x1 is equal to 1 upon a1. What is a1? This is 27. Inside the bracket, this is d1. What is d1? This is 85 minus b1. What is b1? This is 6 cross yn minus 1, so that is y0. So this is 0, and then minus c1. What is c1? This is minus of 1, and then this is z0. So what is z0? This is 0. So we can see this is equal to 85 upon 27. This is 3.148. So this is the value of x1. Now let's calculate the value of y1. Let me keep this x1 safe. So the x1 is equal to 3.148. So now we'll find out the value of y1. What is the value of y1? Let's calculate y1. So y1 will be equal to 1 upon b2. What is b2? This is 15. Inside the bracket, this is d2, that is 72, minus a2, this is 6, cross xn. As we know, we have to use the latest value of x, that is x1. So we'll be using 3.148. Then minus c2. What is c2? This is 2, cross zn minus 1, that is z0. So we'll have 0 here. So the value of this y1, just to remind that for calculating y1 we have used x1 and we have used z0. This is 3.5408. So this is y1. Let me save it, 3.5408. Right, now we will calculate z1. So what is the value of z1? This z1 is equal to 1 upon c3. What is c3? 54. You can see this is c3, 54. Then d3, this is 110, minus a3. What is a3? This is 1, cross the latest value of x. What is latest value of x? That is x1. So this is 3.148. Then minus b3. What is b3? This is 1, cross latest value of y. What is the latest value of y? This is 3.5408. So just remember that to calculate z1 we have used x1 and we have used y1 here. So the value of this z1 comes to be 1.9132. So this is 1.9132. So this is the first iteration, and let me save the value of z1. This is 1.9132. So once we have done with the first iteration, now we can continue with the second iteration, and we'll continue with all these iterations till we get the desired result, or we can perform the number of iterations that are given into the question. So let's say now we will calculate the value of x2. Now what will be the value of x2? This is 1 upon a1, that is 27. This is 85, that is d1, minus b1 is 6, cross the previous value of y1. So this is y1, 3.5408. Then minus c1 is minus of 1, multiplied by z1. So this is 1.9132. Right, because we just to calculate x2 we'll be using 1 upon a1, d1 minus b1, y1, n and n minus 1, minus c1 and z1, because this is n minus 1. So in this way we can have the value of x2. Let me see, the value of x2 is 2.4322. Now what is y2? This is 1 upon b2, this is 1 upon 15, and then this is d2, 72, minus a2, that is 6, cross new value of x2, that is 2.4322. Then minus c2, older value of z, that is 1 point. So let me put a cross, instead of c2 we will write minus 2. This is 2, sorry, this is 2 actually, 2 cross, and the latest value of z, so this is 1.9132. So this is y2, 3.5720. And now z2, what will be the value of z2? 1 upon c3, this is 1 upon 54. Then this is d3, 110, minus a3, that is 1, cross latest value of x. So this is 2.4322, minus that is b3. What is b3? That is also 1, and latest value of y, so this is y2, so we will take 3.5720, and in this way we will be able to calculate the value of z2, and z2 is coming 1.9235. So after second iterations we have the value x2, y2 and z2. In the same way we can continue with more iterations and we can find out the accurate result, or we can perform number of iterations that has been given into the question. So I hope you have understood this Gauss Seidel method and the difference between the Gauss Jacobi and Gauss Seidel method. Thank you so much.